In this video, we're going to talk about the variation with the shift, including the phase shift and the vertical shift. Let's do a recap. Y equals to A times tangent bx minus c plus d. And we got that A is distraction factor, B will help you to find the period, and C will help you to find the phase shift. It will be the same as sinusoidal function, which is the phase shift equals to C over B. If it's to the left, we'll be subtracting. If it's to the left, we'll be adding. If it's to the right, we'll be subtracting. And the D gives you the vertical shift. Okay, now I want you to graph two periods of this function. Y equals to negative 2 tangent pi x plus pi minus 1. Now, if we have a negative involved, do you remember what do we do? What we do is we need to write the function become negative 2 tangent pi x plus pi minus plus 1 first. We factor the negative out first. Or the other way to do it is we know that this is going to be a flip upside down. What you can do is, the other way to do it is to solve this part first. The first term, which is find out what does the graph look like at 2 times tangent pi x plus pi, and then later you minus 1, that gives you a vertical shift. Okay, so either one works. I'm going to work on the first one. So the first step 1, you want to graph 2 times tangent pi x plus pi. And then step 2, you want to flip it upside down. That gives you the negative 2 times tangent pi over x plus pi. Oh, step 2. Step 3, you can just have the vertical shift, which is down 1. Then the function coming from the second step, minus 1 gives you the down 1. So here's it. All right, let's do this. So let's do the step 1 graph. So I have 2 times tangent pi x plus pi. So we got A equals to 2, B equals to pi, C equals to pi, and D we don't consider it now, so we still consider D is equals to 0. That means the midline is still the x-axis. All right, and the period, let's find the period first. The period is equals to pi divided by absolute value of B. Our B is equals to pi, so that means the period is equal to 1. After we found the period, we can maybe work on asymptote, which is pi over 2 times absolute value of B, which is pi over 2 times absolute value of pi, which is every 1/2. Since they repeat every 1, so that means your asymptote has to be 3/2 or 5/2 or continue. And then the next one is we still need to think about the center. We already use not the center. The center is it doesn't have any, they shift to the pi unit. So remember that since tangent is the period for a tangent function, oh, no, let's do this. So the center is going to shift because we have a phase shift, which is c over b. And our c is equals to pi, our b also equals to pi. So that means the phase shift to the 1. So that's very important. And the period happened to be 1, they shift to the 1. That means they didn't really shift the function, if that makes sense. But it would make sense if I start drawing the graph. Let's label everything that we know, and then later we talked about this guy, the stretching factor. Okay, so we have 1, 2, 3, 4, 5. And the period, the asymptote is every 1/2. So that means here's the asymptote 1, and another asymptote would be 1.5. And this, since we only need 2 period, we can just keep it to here. And then we know that the center of the graph should be what? 0, 0, the original 1, but since you phase shift to 1, this is going to be what? You're adding 1, that means you're shifting to the left 1 unit. So you should have a 0 and -1. So let me make up for this one since it's shifting to the left. So I got this one and this one. Okay, so since there's no flipping, so the graph is going to look like this way. If we repeat them too, it will look like this one. So take a look. This is still look like the normal tangent function because they shifted 1 period. That's very important. The shift is 1, the period also 1. That means they shift 1 period. If they shift 1 period, 2 period, or 3 period, they should look like the same, like this one or this one. Okay, we just need 2 parts. So it doesn't matter that which part that you draw. Okay, the next part I want to talk about is the center. So the center, no, the midpoint, sorry. The midpoint, because that part is a little bit confusing. So the midpoint, the x-coordinate of the midpoint should be half of the center to the asymptote. So if the center is 0, the asymptote is 1/2. So that means the x-coordinate is going to be what? 1/4. Have we got that? And then what happened to the y-coordinate? Well, our stretching factor A is equal to 2. So that means our y-coordinate is equal to 2. Because that comes from tangent pi over 4 is equal to 2. If you times an a to it, which a is equal to 2, sorry, this is equal to 1, so that gives you a 2. So that means the midpoint, we label it in here, which is 1/4 and the 2. Okay, so that's it for this graph. We finished the step 1. Now step 2 is we want to flip them upside down since we take a negative. Now let me draw another one and flip it from the first equation. And we got 1/2 and the asymptote of 3/2. And we have a -1/2. Okay, now after they shift upside down or flip upside down, the function has looked like this way. And again, I still want you to label the center, which is 0, 0, 0, 0, and the not 0, 0, you add 1 to it. So it should be 1, 0, because it repeats every period. And the next thing is label the midpoint. So the midpoint, after you flip it, so these should become what? 1/4, and then -2. That's it. Or you can find another midpoint, which is on the right side, on the left side of the period. Let me use the red, which is in here, which is -1/4, and this should equals to 2 now. Interesting, right? Maybe it's good to label 2 midpoints. Okay, so step 3, what happened to step 3 is you want to have a down 1 that gives you the vertical down 1. Okay, let's do it. Again, we draw this all over again. I want you, if you have a 3-step, I want you to draw 3 graphs. I don't want you to put all the graphs together, since most of the time, most of the people, they just use the same color of pen. So the graph will look like super messy, and then you move down. And then at the end, I don't even know what you're drawing. It's just become a doodle. So please make 3 graphs to keep the homework neat and organized, especially for the quiz. All right. So same thing, we have the asymptote, -1/2 to 1/2. And then we have 3/2. But our center or the midline is going to be moved down. So here should be y equals to -1. So this has become the center. Now let's label everything. So the center from 0, 0 is become 0 and then -1. And in here, it will become 1, -1. Good. Label this will help you to draw the graph. And now the midpoint. So the midpoint also -1. So that means the first one, it will be in here. So the coordinate should be 1/4, and then -2 minus 1 gives you a -3. And then the top midpoint should be from -1/4, and then 2 you minus 1 gives you a -1. Okay, I didn't draw the best graph, but here. That should be your new graph. It should be on 1, should be in here. Because it should be -1/4 and 1. So that's why it's very important, because we are not perfect in terms of drawing. So that's why it's very important for you to label all the points that I need to check. So now we have the asymptote, we have 2 center of the graph, which gives you 2 period, and also you gave me 2 midpoint, and we also have the asymptote. So this graph, it will be 100 out of 100. Okay, so that's it, how to graph a tangent function with the ABCD. I'll see you in next video.